SIPTEX. What is SIPTEX? Well, SIPTEX is what you see here in the background. This is the plant that we have in Malmö. It's the first automated industry scale sorting plant for textile waste, and it's a project that's led by IVL. It's a Vinnova Steg 3 innovationsprojekt. But we have, of course, also many partners that I will present later on. But I want to take a moment to look at this this picture that you have here. For those of you who haven't been or who haven't had the chance yet to go to Malmö and actually see the plant in action, this is what it looks like, and we'll try to point as well if I can do that. Do you see the mouse?
Yes.
Let's see, there. So what you actually have here is that this is a whole plant. What's happening is that textiles are coming in here. They're being spread out so that you don't have all the textiles overlapping each other. They come in here, and then it's pretty much a conveyor belt that goes through 3 different near infrared and visual spectra, where you can then sort out different fractions of clothes. For example, the first one, you could, for example, put it in that you want to sort out 95% cotton, and then that will be sorted out in the first stage. And then there's a second stage where you can then sort out a second fraction. And then there's a third control as well. And then everything ends up here in these different containers, and then it goes to a baling system where the clothes are then put into bales so they can be shipped out. So this is a very short overview of what the plant looks like. If you want to see it in action, there's quite nice videos on YouTube and from on the website from CSAF, which is running the plant, where you can actually see everything in action from start to finish. So that was the plant. And where does SIPTEX actually fit in the whole textile chain? It's in between the sorters and the recyclers. There was a missing link there, that if we want to think about recyclers, they want to have access to customized raw material. They want to have access to high volumes of this material, where you can be sure of the quality of the materials that you're purchasing and buying. And you also want to make sure that the price is relatively low, so that you can use these fabrics actually for recycling. And that's where then SIPTEX comes in as automatic sorting process. And everything that comes into SIPTEX is already pre-sorted. So everything that can be reworn is sorted out. So that doesn't go into SIPTEX, that goes for reuse, of course. But that cannot be reused then goes to SIPTEX, where it is sorted into different fractions. And that's actually where SIPTEX then fits in. Of course, it's not just IVL and CSAF. We have many partners in the project, both to collect their input, but also to do different trials with materials that are sent out. We get a lot of input also on the quality assurance, how should we do it, how can we best do it, because there's not so many, there's not so many similar projects like this that have been happened before, where you actually have to assure the quality of a recycled product of textile. So we have some interesting discussions here, and it's a very nice group that covers the whole chain as well. More about the facility. The capacity of the facility is 4.5 tons per hour, which turns into 24,000 tons per year when it's running at full scale. We have 3 near infrared and visual machines where we can sort out different fractions. And it's about 260 meters of a conveyor belt for those who like to have those details. And the manufacturer of the whole plant is actually Stedelijk Tomra that we've worked with to put this up. And for those of you who want to see the plant, you can contact CSAF at Björgården 20 in Malmö. So what's the purpose of the project? In this step 3 of the project, our goal was to, or one of the goals was to assure that we have a set or a range of quality assured products. And what that means is that we have products of different fabric types, for example, cotton, wool, polyester, where we can certify that it has a specific purity. For example, if we say we want to sell 90% cotton, then that should be 90%. And then it should be quality assured there. But also that we have cotton of the right color. So you can, for example, have dark cotton, you can have light cotton, you can do different colors. That's where the visual spectra comes in to sort that out. But of course, one very important aspect is also the chemical safety. And we've noticed that as well, that as soon as we started the project and started talking with the partners in the project, that chemical safety is one of the very focus points here in the study, where it should be, to ensure that the products that come in, where we don't actually know what they're made of, are safe for reuse, so that also those who recycle the materials and then use those recycled fibers know what they're using. And there's different challenges with that, of course. If you have a new fabric, if you're producing something from raw materials, you have a very good overview of what goes in. You can buy something that's certified, for example, certified materials that you use. The materials will always be the same. Well, with used fabrics, you can see it on the right. It's actually a picture of SIPTEX. You can see it's a very mix of fibers and materials that come in. So there's some challenges with that. And the first one is, of course, like I said, control over the incoming materials. If you make your products from raw materials, you have very much control about what comes in, what you buy. You can do tests on that. And also, if you do the test once, you know that next time it will have a similar properties, the materials, but also it will, if you have certified once that it doesn't contain any hazardous materials, it's probably going to be like that in the future as well, since it's made in the same way all the time. See, at SIPTEX, we don't have that possibility. We have materials coming in from different sources, mostly from Europe, but it's still different types of materials that come in. The materials are produced in different times, so different chemical legislations were active. And of course, we have the pre-sorting where we can sort out, for example, fabrics that have double layers, or we see, for example, old Gore-Tex jackets that we can sort out, so we don't have those perfluorinated compounds in there. So there's a limited control that we have, but it's not, we don't have a very high level of control about what goes in there. And then we have a varying inflow, of course. And then we have bales that come in with mixed materials. So it's not just polyester that we'll have to look at, but we'll also have to look at cotton. There might be fractions of wool in there as well. And then when you work with new fabrics as well, you have there's standards and guidelines that you can follow about what should you check, how should you take the samples, how often should you take the samples. For used fabrics, when we got into the project, there are no such standards and guidelines. But from what I hear, it's being discussed more and more. So there's really something ongoing there, and we see a need for that as well. But when we have the project now, it's something that we focused on a lot in the beginning as well. How should we take the samples, for example? How often should we do that? And then, of course, also the possibility to certify as well. And you will hear more from Ingegerd and Rice at her presentation later on. For example, with Yogotex certifications, you can certify different products when they come out. But in this case, for the material that leaves SIPTEX, it's so the source of the material is so varied that it's quite hard to certify that, because you're never 100% sure of what comes in. So you would, in principle, have to test all the different bales that come in, which would make it very costly. But also certification usually starts at the next stage once you actually have the product or the material ready. And in this case, what we're delivering is more a raw material that can be recycled into a different material, because it will also be blended with different materials later on. So it's in a hard position to certify the material with the possibilities that we have today. One of the first challenges that we had was how do we take a representative sample? You see the bales here. There's you see different fabrics in there. You see different colors. The materials could be from different sources. If we now take a sample from the bale, how do we make sure that that sample represents the whole bale, so that we're sure that, okay, if we send this for analysis to the lab and we get the okay, does that then certify the whole bale, or is there a lot of uncertainty on that? And the way we did that was actually we bought a hay drill. So it's what you see here. It's connected to a drill. It's used for making cores from when you have bales of hay. So those who have a farm, maybe on the countryside, they might have seen this before. It's for taking samples and then sending it for analysis when you have the hails. And what we do is that we take a drill sample. We actually take 15 drill samples at random locations on the bale. Once it comes out, it looks like this. So we still have small discs of material, different fabrics. And here as well, you see a risk that if you would take a few of those and send those for analysis, you might still be biased in what you pluck out. You might pluck out, for example, just the white ones here or just the black ones. Or you might know that, okay, the red ones, they're not what we want. We don't want the red ones. We're just going to avoid sampling them. So there's always this human bias as well, even if you're not thinking about it. So what we do is that we work together with RISE here, that we actually send the samples to them, and they mix it up for us. So they shred the materials and they homogenize it as well as they can. You might hear more about that process later on as well. But then we get as homogeneous a bale as we can, and then we send that for analysis. And then we still do, very often we do, for example, when we do fiber analysis, we do triplicate analysis as well to make sure that we know, okay, what is the variability when you take 3 samples from this material. So we have a good estimate about that as well. It's more difficult with chemical analysis because of the cost, of course. We can't send triplicate analysis. We can't do triplicate analysis all the time. Second challenge, what to analyze and how often. Those who work in the field of hazardous chemicals, you know there's a lot of chemicals that you could focus on. It's hard to always know what you should focus on. There's, of course, regulation. You could make sure that your products comply with the current legislation, for example, REACH or Stockholm Convention. And there's companies that want to go a step beyond that. They, for example, use AFIRM or Eucotex testing. And then there's companies who go beyond that and even go into non-target analysis and see, okay, what else is there? What you see here on the slide is, for example, it's a guideline. So it's a testing matrix from AFIRM where there's recommendations on if you have these types of materials, you should test for it. And these type of compounds, because they're known that they could occur. Eucotex works in a similar way there. This is a report from Chemi, who actually tried to map, okay, what are the hazardous chemicals in textiles? And then they focus both on those existing, but also on non-target analysis, where, for example, IVL's lab was involved to do the non-target analysis. And then you have a very wide scope of everything that could be present in textiles. You also have the study here from IKEA and H&M and their partners, where they focused on analyzing textiles by AFIRM legislation or AFIRM regulations. And what we decided to do in SIPTEX is that the samples that we take and we send for analysis at the moment, we send them to RISE and we analyze them according to Eucotex. It's not to have them Eucotex certified, but it's to analyze them for all the chemicals and all the levels that are included in Eucotex, so that we know, okay, we have this very wide list of chemicals that we're screening for, because Eucotex is quite wide, it goes way beyond legislation. And the goal there is, of course, it would be very nice if we pass that every time, but it's also to make sure that we don't just focus on like the regulatory limits there. So that if a product leaves SIPTEX, of course, it has to be okay with REACH, of course, it has to be okay with Stockholm Convention. But then we also have all the other chemicals and all the other limits that are included in Eucotex, so that we know and we can focus on that. Okay, what else is there? So that we know the next step. Maybe we see a certain chemical occurring here and there, and then we could think about, okay, maybe there's something in the inbound material that we could sort out. Maybe there's something there. So that's why we chose to use to work with Eucotex at the moment. And we're also thinking about, once we have enough of the materials, once we have enough of the samples, then we can start also thinking about, okay, these chemicals never occur in our materials. These occur sometimes. Maybe we should do more frequent screenings for them, and then do a Eucotex screening now and then. So these are all like challenges that come into play here. Third challenge, upscaling and communication. What I mean with upscaling is that, of course, now we know how to take samples of one bale. We know what the results look like for that. But as we've seen before, there's going to be 24,000 tons running through the plant. How do we upscale that process? How do we now convey those results? Like, how often should we sample the bales? How many bales should we sample? And that's something that we're working with now as well, to see, okay, how do the results translate into ensuring that all the bales are safe? And that's something that we're working with. And we're also working with communication. How do we then, now that we have all those results, we have results from our other studies that have been done. For example, the one I showed you from Chemi, the one I showed you from H&M and IKEA. There are studies from RISE as well on recycled materials for textiles. How do we package that in a way that we can communicate to the customer that, okay, this is this is what we know about hazardous chemicals and textiles, and how do we do that in a transparent way, but of course supported with a lot of the data. And that's what we're working with now as well. I was also asked to talk a little bit about mechanical recycling. And here I got some slides from my colleague at IVL. Talk a little bit about what's included in mechanical recycling and then also the pros and cons. And then if we look at how mechanical recycling works, there's first, of course, the recycling, where you get, for example, the materials that come from SIPTEX. You sort them out, which is what SIPTEX does, sort them by fiber type and color. You then clean, of course, all the trims. So you want to remove all the buttons and the zippers. You cut the fabric into smaller pieces. You shred them. And up to now, it's very similar to actually what we do for the chemical analysis as well when we send our samples to RISE. And then, of course, you do a quality check of the fibers, the fiber length, the fiber strength. And once you have that, then you start actually with the textile production. So then you will mix in virgin materials, strengthen the materials, because very often the recycled fibers might have a little bit of lower quality. So you have to mix in some virgin material there. You card the selected fiber mix, you draw them into the same direction, and then you spin the yarn. Unless you're doing non-woven, where you don't have to do the yarn spinning and then produce the fabrics. That's very short how mechanical recycling works. And then the pros of that is, of course, that if you do the mechanical recycling, you never need 100% of virgin raw material in your process. So you would be there in accordance with the waste hierarchy that you try to use more recycled materials. You also preserve textile fiber material value at a higher level compared to, for example, chemical recycling. And then if the input textile is carefully pre-sorted, then sometimes you can skip processes such as the yarn or the fabric dyeing. This is, for example, something that we've also seen in another project with, where they use recycled wool. They use different fractions, different colors of wool that come in. So there's post-consumer wool. And then they mix those different batches together to get a new color. And so they don't have to do the dyeing again, which saves both money and time there. And then, of course, it's also a suitable recycling method for production waste. So they have a very good idea about what is the, what are the properties of the material, what chemicals could be included there. It's a pure material, so it's very easy to use for this type of recycling method. And then it's also the only recycling method that generates or maintains cotton fiber's original molecular structure, which makes it stronger in the end. The cons, you need very careful sorting, both fiber type and color, in order to get a good quality of the recycled fabrics. So you need a high quality input in order to get a high quality output. And here's, of course, where SIPTEX also comes into play to actually deliver on assuring that you have a fiber type, or that you have materials that are quality assured, both for fiber type and color. Also that you would always need, or almost always need, to mix in new fibers, so virgin fiber material, in order to get a good quality. And that's since the incoming material is so varied in their quality, that it's difficult to achieve even quality over time. You might have some batches that might look a little bit different than others. And then, of course, also removing the trims, such as the zippers and buttons, is very important here. And that's something that's not included at the moment in SIPTEX yet. So the materials that are sent out from SIPTEX still contain, for example, zippers and buttons. And there we're looking into as well what are possibilities here to remove those. And with that, I would like to conclude my presentation. If you have questions, you can always contact me. So that's my name right here, or you can contact the current project leader as well, which is my colleague, Maya Nelstrom. If you want to look more at images or videos of the plan in action, please visit CSOF's website, where they have a lot of additional information that you could look into. Thank you.